Yeah, but it's gonna take a while to multiply 3.14 times whatever.
All right, here we go. Quiet, please. Homework's out. Questions on the homework? Yes, Kylie. Number. Kylie. It would be easier if we just changed your names. Exactly. Go ahead, Kylie. Hey, everybody else, hush. Number 7. Let's take a look at number 7. Number 7 says that you have a V and a B. We know that all prisms and cylinders, well, the formula is V is equal to BH or V is equal to pi r squared H. Either one's fine. Pi r squared H doesn't work for a prism, but it does work for a cylinder. So on number 7, we are told that V is equal to 36, and we are told that B is equal to 12. So what we don't know is H. Solve for H. What do you do to both sides? That's it. That's literally all you had to do for that one. All right, anyone else?
This one looks like a pizza.
All right. Check your work. Let's go. Here we go. 1 through 12 all. Number 1. Now these are all in volume, so the units will be cubed. And until you get to number 7, there are no units listed, so it'll be units cubed. Number 1 is 314 cubic units. Number 2, 1,810 cubic units. Number 3, 12,600 cubic units. Number 3, 12,600. Number 4, 39,300 cubic units. Number 5, I had a bunch of people come to me during student advisement. How do you do this? I said it's a pipe. Pipe is a cylinder that's hollow. So the calculation would be the big thing, the whole cylinder minus the small cylinder, the hole in the cylinder. The hole in the cylinder is another cylinder. So it would be pi r squared H minus pi r squared H. But it's 2 different size cylinders. They both have the same height though. Long story short, and by the way, it says leave the answer in terms of pi. So the final answer is 60 pi cubic units for number 5. Number 6, it's half of a cylinder. So you calculate the whole cylinder and you divide it by 2. Number 6, 1,000 pi cubic units. Number 7, the one that we just did, Kylie, the answer is? It's 3 centimeters. Number 8 is 2 millimeters. Number 9 is 4 meters squared. Number 10 is a half or 0.5 meters squared. Number 11 is 4 units. And number 12 is also 4 units. And that was it. All right. Don't ever forget, I don't forget to put zeros in the grade book when you don't do your homework. During lunch, that's when I do all my grading because I have my planned periods right after lunch. So I sit there in the teacher's lounge with all the homework and it immediately goes in the grade book. Okay? Don't be that kid that you're losing 3 points. They're basically free. Do your homework, you get 10 points. Whether you get one right or all of them right. Do your homework. Don't write random numbers down, but do your homework. Come to class with questions on the ones you don't understand, like Carly just did. You're going to mess me up. The problem is that in 8th grade, there is another girl, or 9th grade actually, 9th grade, there is a Kaylee. And guess what I called her all last year? Kylie. And then every day she would say, Mr. C, it's Kaylee.
Is it Missy's older sister?
Yes. And so now I'm accustomed to saying Kaylee. It only took me a year. And now I got a girl named Kylie, and now I'm really screwed up. Yes. It's not your fault, Kylie. My fault. The ones that I helped you on that you came to the answer, I saw you did them correct. Okay, pick one.
4.
Number 4. His looks like a dime or a quarter, right? Laying flat, right? A pizza, right? We're told that from here to here is 50, and it's really skinny, and it's only 5. So what's the formula? Okay, what's the radius? We got to square it, and the height. This is why I was like, okay, she's going to get it right. I don't know what you did with your calculator after that, but yes, that is correct. So grab your calculator. Yeah. And then you tell me what you're typing into your calculator as you do it. Okay, how are you typing that in? With a square button or 50 times 50? Okay. Okay, keep talking. Keep talking. This is why I'm not worried. You just said it perfectly. If you have a mistake,
But it's not the right answer, as you said.
what did you get?
39,200.
They're just rounded differently. The instructions actually say round to 3 digits, so the first 3 digits. You got the right answer. Relax. All right. Okay. Make sure your names are on and pass them to the left. To the left. To the left. To the left. Nice. Do something for me.
I'm doing my homework.
That's why I'm making you do that, because that's your penalty for not doing your homework. All right, everybody else, look at the board. Let's see. We calendar away. We made it to Thursday. Tomorrow's Friday. We are going to do the 2 most complicated formulas today and tomorrow. They're not hard. They're just formulas, right? But they do require the most work. Tomorrow's is pretty long. It's the longest formula we have so far this year, but it's not impossible. We'll do 2 days of review on Monday, Tuesday. We'll take the test on Wednesday. And then it's right after here that like next week, you're going to see spring break appear on the calendar. All right, worksheet today. There will be 8 problems. Yes, there's 8 because they take a while to do. Each one takes about, I don't know, maybe 3 minutes if you're quick, 5 minutes if you're slow. There's 8 of them. For you slow people, yeah, it's going to be over 30 minutes worth of homework. For you quick people, it's, I don't know, 10, 15 minutes. Worksheet, worksheet, worksheet. Vielen Dank. German for thank you very much.
I thought you said you're feeling dumb. That's what I heard.
And that's the words.
Good night.
Say feeling dank. Except dunk.
Feeling
I don't
dank.
like that.
D-A-N-K, but say dunk.
I'll do this.
Why are you
Duh?
dank?
D-A-N-K, not D-U-C-K.
You like drunk with a car.
With an A, not a U. Vielen is spelled with a V though. V-I-E-L-E-N. Vielen, that means a lot of. Dank means, it's the same word in English, except their D is our TH. Many thanks. That's how they say thank you very much. Many thanks, they say.
Weird.
We say the same thing, some of us, many thanks. All right, today we're going to be doing surface area. Stop what you're doing, look at me. We have done area. We've done area of rectangles, squares, whatever. We've done volume, 3-dimensional shapes. Today we do a third thing. It is area, except it's called surface area. Surface area, as the name implies, is what you can touch. That is the surface of an object. If you can touch it, right, it's on the surface. In order to get to the inside, you got to cut it open, right? So anything you can touch without cutting it open is the surface. If we were to spray paint this shape right here, where the spray paint would touch would be the surface. That's the surface area. That's what we're doing today, is calculating that area. Area is not volume. Surface area, like normal area, will be, the units will be square units. Okay. All right. Area is in 2 dimensions. You're like, well, wait a minute. Surface area, that's 3 dimensions in a way, right? However, you can take the area, you can lay it flat. And that's why we can consider even surface area an area. Next year, we will actually take a 3-dimensional object and make it flat. We'll squish it down. We will peel the skin off of it and lay it flat on a flat surface.
I don't like that. That sounds
Okay.
like a murderer would say that. Yes.
That's why we're dealing with inanimate objects.
All
right.
What about your monster movie where all the shapes
we're
are
not-
alive?
We're not going to be doing surface area of a monster movie. All right, today's class is on surface area. So let's write this down, box 1, please. The definition of surface area is the total area. The total area, right? The total area of the surface of a 3-dimensional shape. The total area of the surface of a 3-dimensional shape. The total area of the surface of a 3-dimensional shape, surface area. Take a shape, 3 dimensions, your calculator, your cat, whatever. Spray paint your cat. No, we can't do that. Think about how much surface is on the surface of a cat. Right? It's a lot of surface. That would be its surface area. Yeah, then, now we're horror movies, right?
Yeah.
Maybe already does that with like deer.
Well, that's right. The skin of a deer is the surface area of a deer.
You assume and then you're lucky.
So do you.
No, it's you.
What did you have for lunch yesterday?
I had cereal.
We had
I didn't have lunch yesterday.
Oh.
I was hungry.
Yesterday, you guys had what for lunch? What?
chicken
It's chicken. You ate the inside of a chicken yesterday.
No, I didn't. I was hungry.
It was good. Well, let's hope it was cooked. All right, back up here. Back up here. Back up here. All right, surface area. Total area of the surface of a 3-dimensional shape. Recall that we had prisms, and no, since you complained so much, I'm not having you redraw the prism. It's already there, box 2. We will label the parts of the prism. The parts of a prism. The 2 triangles are called?
Faces.
Label that. Now, where my arrow is coming to, it's 3 dimensions drawn in 2, so it's kind of hard to see. What the arrow is pointing to is to the triangle on the bottom. John, put the calculator down, grab your pencil, and start writing the definitions. What's your calculator's name?
Joey.
Joey is going to be right there.
That's my calculation, not
Yeah.
his. I think
You
this
should
is-
all name your calculators.
That's why. What's your calculation?
It has a name. It's called calculator.
Brenda.
Brenda.
I'll name it IDK.
If we name your calculator, are you cheating on your wife since you married?
My wife's name is Brenda.
Oh my god! Oh god, I really
All right.
cheating on Brenda with Brenda.
Okay, the sides of a prism, right, are called, if you remember right, the faces. Now, we call them the lateral surface. Lateral literally means side. So it's the surfaces that are on the side. We call those the faces of the prism. Okay, right?
I did.
Those are the parts of a prism. Now, I drew a triangular prism. That is also true for a rectangular prism. Today, we will be calculating the area of those 2 surfaces.
Not a
The
cylinder.
surfaces of the tomorrow.
Oh no.
Surfaces of the bases and the surfaces of the, the area of the bases and the area of the faces of a rectangular, and triangular prism. Tomorrow we'll do cylinders. Yeah, exactly. See what I mean? So the bases are the 2 triangles. So those 2 arrows are pointing to the triangles. The faces, remember the sides of all prisms are rectangles. So it's pointing to the sides. Lateral literally means side. Okay. There is a formula for this. I choose in 7th grade not to show you the formula.
Great.
Okay. Instead, I have a technique to calculate surface area for prisms. Next year in 8th grade, you will learn the formula. It's not that you can't learn it now. It's just, it's complicated. You don't need this complication at this point. There's another way of doing it that makes a whole lot of sense. And it also allows you to understand where the formula comes in next year.
So it allows us to calculate it, but also you explain it how it works. You explain it to us how it works. At the
If
same
we
time.
do it one year by doing it this method, next year when you encounter the formula, you won't ask, well, where's that formula come? I don't understand it. Okay. All right. So here's the trick. We will be calculating today surface area of prisms. Okay. There are 4 steps. Write this down in box 3. Step number 1. Write this down. You're going to name the sides. Literally name them. Okay. You could, except I would suggest the names that I will show you here in a second.
Like A, B, and X.
You could, she said name them Fred, Joe, and Stan, right? You said A, B, she said that. You said ABX, and I said those are both options. We are going to choose words that are far more descriptive that help us out. Step 2, once you've named them, you're going to identify what's the shape. Because look, on a triangular prism, well, you got different shapes. Sometimes I have triangles, sometimes I have rectangles, sometimes I have squares. Same thing for a rectangular prism. Sometimes you have squares, sometimes you have rectangles. Like, wait a minute, rectangles are squares. I'm sorry, squares are rectangles.
A rectangular resource cup.
And that is true. Step 3, you're going to calculate the area for each one of the sides. If the surface area is defined as the total area of the surface of the shape, well, then you got to calculate all the area of each shape. There lies the problem. How many sides? Rectangular prism. Richard, wake up. How many sides? So guess what? You have to do 6 calculations to do this. How many sides of triangular prism?
Too many.
So guess how many calculations?
5.
5. 6 for this one, 5 for this one. To do surface area. Surface area is the hardest calculation. Step number 4, once you calculate all the areas, if the definition was the total, well, then you total them up. It's just 4 steps. Identify the shape, name the shape, identify it, calculate the area of that shape, and then add up all the sides. Yeah.
Don't we already know how to do the area? So it's just
We
more time.
certainly do.
So it's more time consuming than it is hard.
Exactly.
That's so interesting.
All right, 4 quick steps to write down, not 4 quick steps to actually do. The slow kids, like I said, it might take you 5 minutes to do one of these. For the quick kids, it's still minutes. It's not like I can do one in under a minute. It's going to take you some time.
Can you do one in a minute?
Yeah.
But I mean, at least these shapes are sort of basic.
Well, wait till we get to the last one and I'll do it for you.
The shapes are basic, though.
The shapes are basic. Hey, by the way, there's only 2 shapes here. What are the 2 shapes?
Triangles and
Triangular
rectangles.
prism,
That's
squares.
it. There's just going to be triangles and there's going to be rectangles. So it's not that we got, oh, wait, what's those other formulas? We don't have to worry about that.
They're kind of just both the same, except one of them you just have to divide by 2.
That's correct. All right, watch me. Put your pencils down. Watch me do one.
All right.
Here's the drill. Prism. This one is a rectangular prism. It's a box. Surface area. That's how much area is on the outside of the shape. Okay. Well, step number 1 said I got to name them. No, I'm not going to name them ABC or Fred, Joe, Stan. I'm going to give them more common names. Jake, what am I going to call this side?
4 centimeters.
That's its name, 4 centimeters?
You could call him.
It's going to have a hard kindergartner writing its name.
His name is going to be Fox. It's Foxtrot.
What are we going to name the front?
Square.
Square.
How about we name the front
No.
the front?
1.
I mean,
Could you make a mistake if you call the front the front? No. If you call it Fred, well, then there's debate about where is Fred. But if you call the front, you won't make any things. So it's got 6 sides. What are we going to name them? Side to side, we're gonna make a mistake.
Left, right.
Left, right.
Top, bottom, left, right.
What if I did the right side, the left side, the left side, the right side, the back side?
Let's not do that. All right, so yes, and it is a recommendation, by the way. I'm gonna name them these 6 words: top, bottom, front, back, left, right, or right, left. And the order doesn't matter. Those are names that are easy to remember, and they are hard to make a mistake on. If it says go to the right side, well, you don't go to the top. The hardest thing in this procedure is not this step or even the next step. Well, the next step is we've got to calculate the area of each one. Well, what's the shape of the top? What's the shape of the top?
It's either the rectangle.
Okay. What's the shape of the bottom?
The rectangle.
What's the shape of the front?
The rectangle.
Hey, it's a rectangular prism. Guess what? They're all rectangles. Well, that's not hard.
Identify shape.
That's not hard. The hard part, and by the way, what's the formula?
Length plus width.
That's not
I mean, length
hard.
times width.
What's hard is finding the numbers. So watch me. I will have plenty of students, you'll understand what to do, and then they won't be able to find the dimensions,
Go ahead.
the measurements of the length, the width. Here is your recommendation. For those of you that have problems, draw that rectangle. If I'm doing the, I'm doing the top, sorry. If I'm doing the top, well then draw the top. How long is this piece?
That's 12.
How long is this piece?
2.
Where'd you get that from?
Because it says that the width down there is 2 centimeters.
There is no number here or even here, but
But the
below
sides are
it,
identical.
it does, and it has to be identical because it's a rectangular prism. So that means it has to be 2. Do you see where I got those numbers from? The length is 12 and the width is 2. 12 times 2 is 24.
And then you can use the
Now here is the magic. On any rectangular prism, the top and the bottom,
Are the same.
the same, so you can just times that
so
by
I
2.
only
and
have to
divide
do
by
this 3 times. I have to write 6 numbers, but I only have to do the math 3
That
times.
doesn't seem that bad,
The
actually.
top is the same as the bottom. The left is the same as the right. The front is the same as the back. So I really don't do it 6 times.
So we
I'm
just-
doing it 3 times.
So wait a minute, does that mean for the
Hold on, let me
triangular
finish.
prism-
Let me finish. Okay. The top is the same as the bottom. So even though I will show you the math,
you can
as
just
soon as you write 24, you can write it a second time. Or multiply by 2. Okay. The front. Once again, if you can't see the numbers on the front, you outline the front. So the front clearly has a length of 12. What's its width?
4.
Does everyone see it's 4?
Yes.
Okay. 12 times 4.
48.
And if the front's 48,
Back.
The back's 48.
that's 48. Even though you're going to see me write that down, you don't have to write all of this. You can just write 48 again, or 48 times 2.
It's easier because you have a calculator.
Correct. Right side. Here's the right side. What's its dimensions?
That is 2 and 4.
Okay, now he's got to stop answering questions, and the rest of you have to stop me if you don't get where he's getting those answers from. 4 and 2, yes?
Yeah.
Okay, 4 times 2 is 8. And if the right is 8, the left is 8. So even though I show you all this stuff, I'll have kids say, do you want me to write all that? Well, you can. By the way, it's never going to not be a rectangle if it's a rectangular prism. It's always going to be a rectangle. It's always going to be length times width. So this middle part right here, I showed you there to show you where I'm getting these numbers from. But the reality is that you need to write top, and 12 times 2 equals 24. That's what you need to write. Okay. That was step 1, 2, and 3. What's step 4?
Add them all up together. 21 plus 24 plus 48 plus 48 plus 8 plus 7.
Are we doing volume or area?
We're doing area.
That's why it's to the second power. Area is always to the second power. Go ahead, Connor.
Does this mean that for the triangle?
Let's keep that till we get to triangular prism.
I don't like that.
All right. Now, I said that for the slow kid, this is 5 minutes worth of work. For the quick kid, it's at least a minute or so, right? You have to look at the shape. You have to figure this out. But it's not an hour's worth of work. But it is a lot of work. More work than we've done on any other shape. Okay?
But it's not hard.
It isn't hard, but it's a lot of work. All right, so let's do one. Box 4. Grab your pencils. Let's do it. What? No, it's fine. Right? So what are we going to call them? The sides?
Front, top, right.
So make sure you are doing this. Everyone do this. Richard, grab your pencil. Let's do this. So we're going to name them top, bottom, left, right, front, back in any order that you want. There's 6 of them. Right. Top, bottom, front, back, left, right. So you're like, can I abbreviate? Okay. Problem is there's 2 B's. So B-O, B-A. It's a rectangular prism. All the sides are the rectangles. So I'm going to write the word rectangle, but you don't have to. All the shapes are rectangle. All the formulas are length times width. I'm going to write length times width, but you can skip that. All right, let's look at the top. There's no numbers on the top. Well, then look at the bottom. What? There's no rectangle on the bottom because it's covered up. You can't see it. However, if the bottom is 8, that means the top is 8. If this side is 3, that means the top is 3. So it's 8 times 3. Does anybody not see where I got 8 times 3? Yes, good. Do you see 8 times 3 for the top? Okay. 8 times 3 is 24. Yes. Well, I need this length. This is the length. This is the width. Well, there's no number here, so I look directly down. It's 8. There's no number here. I look directly down. It's 3. Okay. 8 times 3 is 24. And here's the nice thing. You just did the top, so the bottom has to be 24 as well, too. Okay. Cool? Jake, the front. What are the dimensions of the front?
The dimensions of
It's on your paper, too.
oh, right. It's 8 centimeters.
That's 1. That's the length. What's the width?
The width is 8.
Look at the paper. Look.
4
It is. So that would be 8 times 4, and that's 32. If the front's 32,
then the back is 32.
you're going to see me write all this. You don't have to write that.
What is the front?
I'm going to call this the front. 8, and then this side, it's not there. Look over here. It's 4. And remember, it's going to get worse when we do a triangular prism. Your eyeball will flip around, and it's hard. Triangular prisms are harder.
Well, this is already flipping around.
Agreed.
It's just-
All right, the right side, here it is right here, 3 and 4. You see it? That's 12. And if the right is 12, that means the left is.
12.
Last step.
Add them up together.
Somebody said, well, without a calculator, this isn't too hard. I agree.
But you're probably gonna make them 136 and 100.
By the way, these are easier ones because the numbers are nice and friendly. We get to quiz and test day. Wait, we already taken the quiz. We get to test day. I can put any number I want, large or small. You got a calculator in your hand. It's not that big of a deal. 24 plus 24 plus 32 plus 32 plus 12 plus 12.
136 and
Or you could do 24 times 2 plus 32 times 2 plus 12 times 2.
Or you could just add them up before that. And then
48 plus 64 plus 24. What do we get? We did that in less than 3 minutes as a class. That's a lot. I mean, I filled up the whole darn screen full of numbers there. Now, why? Because I also wrote all this. For me, when I'm literally doing it, top, bottom, front, back, left, right. 3 times 4, 12. You see what I'm doing? Maybe it's 6 times 4, 24, 24. 8 times 1, 8, 8. Draw a line. That's what I would do. That's how much writing is required, or the minimum amount of writing that's required. Okay? It's still a lot. It still requires you to pause, make sure you look at the numbers, and that you're filling in the right numbers. That's the procedure for finding surface area of a prism.
But why do you have to write like the same thing so many times?
When I do it, I write top, bottom, front, back, left, right. And then I look at the top and I say, oh, look, it's 6 times 4. And that's 24. And the top's 24, the bottom's 24.
Yeah, but then you write on the slide.
When I look at the front, I get the two numbers. Maybe it's 6 times 2, 12, and the front's 12, the back is 12. And I look at the back, maybe it's 4 times 3, that's 12, and the other one is 12. And then I add. That's what I do. Why am I showing you all of that? Because I'm the teacher. I'm showing you where all this stuff comes from.
My chart.
Because they're all rectangles.
Yeah.
Guess what happens on the next shape?
It's a rectangle.
They're not all rectangles, and they're not all triangles.
Wait, they're
There's triangles and rectangles. All right, one more. Here we go. See if you can beat me to the answer.
I already did.
All right, number 5. So step number 1, I write front, back, or top, bottom, left, right, front, back, however, whatever order you like. Addition is commutative, so it doesn't matter. Nathan, you already got the answer. Put all that stuff away, do the math. The top, it's a rectangle. Well, they're all rectangles. Why am I writing rectangle 6 times? Well, because I'm the teacher. Are you going to write rectangle 6 times? I'll be lucky you to write rectangle once. Right? I look at the top, it's a rectangle. It's 2 times 1. Hey, that's 2. If the top is 2, well, the bottom's got to be 2. I look at the front, it's a rectangle, length times width. It looks like it to be 2 by 8, 2 by 8, 2 by 8. 2 times 8 is 16. If the front's 16, the back is 16. I look at the right side. It's 1 by 8, 1 by 8, 1 by 8. 1 times 8 is 8. If the right is 8, the left is 8. Now I have to add. 8 and 8 are 16. 16 plus 16 plus 16 is 48. 48 and 4, 52. Without a calculator, I got 52. Let's see, units were centimeters, square centimeters. No, the numbers will not be that friendly on a test thing. But you're going to have a calculator. It's just a matter of calculation. Who's lost? Who's actually awake? You guys are like falling asleep.
I almost fell asleep yesterday, and then my foot kept twitching. And it hurt. So it woke me up.
Your foot has a mind of its own?
It was twitching.
All right. It turns out that the problem child, I called it problem child the other day, the rectangular prism is actually the easier of the two. The triangular prism, well, it's not that much harder. The problem is that you have different shapes. You have a combination of triangles and rectangles. So triangular prism, I'm going to skip box 6 because no one is questioning me and everyone seems to have this idea. Is that correct assumption?
Yeah.
Okay, so we will skip box 6. Anybody do it?
I did actually.
What'd you get?
It was 90 centimeters squared.
90?
92.
I got 90.
Yep.
Carson, you got a mistake or somewhere. You got 22, 22, 22, 22, 1, 1.
Oh, geez. I missed that.
All right. So let's move on to the more challenging shape. It's not that much more challenging. But now you will come to realize, Maddie, of why I put the words rectangle where I did, because they're not all rectangles. So it's still the same steps. But here's the problem. It doesn't have a top. Okay. So let's see. Bottom is still the bottom, but what am I going to call the other sides? Bottom is still there, but what am I going to call the other sides?
Couch. Kitchen.
I got a left, right, and a back and a front. That's what I'm going to call it. Now, depending upon how it's positioned, you might be missing a bottom, you might be missing a top, you might be missing a left, you might be missing a right. It just kind of depends. You get to come up with these names. These are suggestions, by the way. But no, I would not call them A, B, C, that sort of thing. Okay. Notice my triangle doesn't have a square on it, but it does off to the side here have a line pointing straight up and down. Guess what they're telling us? That's the height of the triangle. Okay. So the bottom now becomes important to understand the shape. What shape is the bottom?
Rectangle.
What shape is the front?
Rectangle.
I heard both answers, triangle and rectangle. The front is what?
Rectangle.
Why do you think it's a rectangle?
On the front.
There's no front.
To my eye, it's looking like this. That's how it's to my eye. Is that how it seems to you?
Yeah. that's how-
Yeah.
Well, the front is clearly not a rectangle, it's triangle. The back is a,
His eyes.
well, it could be, right? The other way that I see it, if I make my eye go that way, it's like this, and the front is still a triangle. I see it either like this or like this.
Wait, what is the front or like
If I turn it like this, the front is a rectangle, right? And it could be, the front could be a rectangle. So then the left and the right would be your triangle.
yeah, I see the
Really make a
I see
difference?
the rectangle that's
Okay. I do too, by the way. All right, the back is also a triangle, and the right side and the left side are your two rectangles. Okay. Everyone look at me. This is a equilateral triangle. If it's an equilateral triangle, all the rectangles will be the same. It's an equal, all three sides of the triangle are the same. If it's an isosceles triangle, like this one, two of the rectangles will be the same, the third will be different. If it's a scalene triangle, that means all three sides are different of the triangle, then all three rectangles will be different. This is the one that can kick your butt, triangular prisms. So you got to do them one side at a time. Sometimes you get duplicates, other times you don't, depending upon whether it's a scalene, isosceles, or equilateral triangle. Okay, this one is isosceles. All right, so the bottom is a rectangle. Sometimes it just helps to draw the rectangle in dark. Well, there's the rectangle. It looks to be 12 by 4. Do you see that? So that would be 48. Okay. The front is a triangle. What's the formula for area of a triangle? Front's a triangle. Formula?
pi.
Radius pi for a
No,
triangle?
1/2.
Base times height divided by 2, or 1/2 base times height. So that's the formula. The base, well, typically we have to find a little square. There's no square here. Off to the side, there is a height. It's coming from the bottom of the triangle, and the bottom of the triangle is 4, therefore it's the base. So the basis of the triangle is 4, and the height is 6. Does everybody see that? I don't like this one. I want square, right? But the base is 4, and the height is 6. 4 times 6 is 24. Half of 24 is 12. Here's the only thing you can be assured of for triangular prisms. Once you calculate one triangle, the other triangle must be the same.
Well, actually, you don't have to do the division because then you would just be. So if you're doing the other, you would have to. Do the
You're
division.
way ahead of everybody else.
I did all
100% true.
and I think I
I
got
know.
them right.
I know, he's right. For the rest of us out there, yes, absolutely. The front triangle and the back triangle are exactly the same. Okay. If you understood what Connor said, then you absolutely use that. If you didn't, then don't worry about it. Then don't worry about it. You're good. The front and the back were both triangles, and both triangles have the same areas. The sides may or may not, meaning the rectangles may or may not. The right side, well, I've got a 12 and I got an unknown distance. Well, the unknown distance is 7. 12 times 7 is 84. Notice I got 84 on the bottom, and I'm sorry, 48 on the bottom, and on the right side I got 84. Definitely different. Why? It's isosceles. Okay? Isosceles, we're going to have two different sides. On the right side I got a 7 and a 12. Well, that's also 84. So it's isosceles. So 2 of the rectangles were the same. The third one was different. Equilateral, they'll all be the same. Scaling, they'll all be different. This is the one that kicks people's butts. Well, the nice thing is we simply add to get to the answer.
If it's a triangle, it's still squared.
One more time.
If it's a triangle, it's still squared.
If it's a prism, it will still be squared for the answer, yes. Whether it's a triangular, rectangular, or hexagonal. You will not have a hexagonal.
I'm wondering how we do the cylinder.
Tomorrow.
Yeah, this is pretty interesting.
It takes a long time. And
In my opinion,
what happens when you have this much math?
your brain hurts.
The chances of making a mistake go up or go down? It goes way up. The more math you have to do to get to one answer, the likelihood of you getting it correct go way down, because all you have to do is make one little mistake and it throws it off. So, I mean, if we actually count the number of steps, as in multiply 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 steps here for one problem. You got to plug in the right numbers. There's one step. You got to multiply. There's 2 steps. You got to add. There's your last step. A lot of math to chance to make a mistake or high. Yeah.
I just want to know why you put things around the number instead of having.
Well, it's not 127, is it?
Yeah, but can't you just put like a dot?
You can put a dot.
There.
Yeah, sure. You want to know why I don't use dots?
Why?
Because you've seen my handwriting, pretty sloppy. So if this wasn't a 4 and it was a 3.6, right? Then I would have, where's the decimal? Is that 3 times 6.12, or is that 3.6 times 12? You see what I mean?
Or 3.
Well, those are the 2 ways, right? So for me, I don't use dots because I'm sloppy. I use parentheses, and then there's no chance of me making mistakes.
Can't you use those little star things?
You can, but then how long does it take you to make a star? And I'm like, well, it takes me shorter to do that than to make a star. Granted, a dot is the quickest way, by the way. I just know that there's a chance of me screwing it up and confusing it with a decimal. All right. Yes.
On the quiz, would I still have to put, for example, 4 times 3 equals 12 divided by 2, and then I would have to times it by 2 again, or do I have to show that one for doing that?
I'm okay with you skipping that.
The wedge thingy, like is that a top or the left side?
Agreed. So there's complications of how you want to name it. So here's what my suggestion is. I want you to name them so you understand.
Wedge.
If you don't like those names, you come up with your own names that make sense to you.
What if you don't feel like naming them?
You have to give them some sort of name, because what will happen is you got to do the calculation and then you might forget one, right? You don't have a name.
Well, it's like saying if
Can I just name them like 8 times?
If it's like 4 kids and you're not going to count and you're not going to name them, hey, Fred, Barney,
Bill.
Bill, and
Joey.
Can I
Joey,
name them the
are
equation
you
of-
here and you don't wait for them, or you don't count 1, 2, 3, 4, and you just kind of look at it, look about here. Name them. Make sure they're all
I
there.
didn't name them this time, so let's see if I got them posted.
Okay. So here is a scalene triangle. One side is 5, one side is 12, and the other side is 13. All 3 rectangles will be different. If it's scalene triangle, all 3 rectangles will be different. Okay. Now this is the one that where Danny is saying, like, well, what do we name these things? Okay, bottom is pretty obvious, right? Well, maybe left is obvious, but what are you going to call this one?
Right.
I just called it front.
Slant, right, top?
I called it top.
Some people like I called it top as well too. But some people like, that's not the top, that's the right. Okay, great. You're fine. As long as you understand your naming. Okay. If I had to make an argument that it was the top, it would be a weak argument. When maybe left and right are the best names. I called it top, but we're okay. I'm not going to confuse left with top, right? Okay, so I'm going to call them bottom, front, back, and then top and left. You may call the top the right if you think it's the right. That's fine. All right, here we go. What's the shape of the bottom? What's the shape of the front and back? They're triangles. And then the top and the left side, or the right and left side, are both rectangles. Okay. The bottom, that's kind of easy to see. What are the dimensions? The bottom? 12 times? 12 times? 10. I didn't hear what you said. All right, 12 times 10, that's easy. That's 120. Remember, since the scalene triangle, all 3 rectangles are going to be different sizes.
Yeah, but
Triangles are going to be the same.
but the 12 is just 1 off from 13, so you can just subtract 10 from 130. I mean,
Well, let's see if that's true or not.
So you could just add 10.
All right, well, let's see if that's true. All right, the front is a triangle. Well, we do have a square here, so there'd be a square here. So the base and the height are 5 and 12. 5 times 12 is 60. Half of that is 30. Do you understand what Connor's point was before?
Or you could just.
Oh, let me talk. You talk too fast. Connor's point was, well, to find that, you do base times height, and then you divide it by 2. But if there's 2 triangles, then you're going to double it anyway. So how about you just do base times height? And then you have the whole thing. And I agree with that. Okay. For those of you that didn't understand that, then do the 2 triangles, 30 and 30. Which is base times height. The top, which some of you call the right, is this square or this rectangle right here. And that looks to be 10 times 13. So Connor said, well, then it's going to be 10 more than the previous one because it's 1 more. If the previous one was 120, 10 more would be 130. So he is correct. Okay, if you didn't understand that, it's 10 times 13. The left side is the hardest one to see. It's right here. It's 5 on this side, and the top doesn't. Neither one of them has a number.
Well, they're both the same, so.
But way over here, there's a 10, and so that would be the same over here. Last step, we add everything together. Jake, if I look at your paper, you got all this filled in, yes? Okay. So remember, in a math class, especially when you're doing something for the first time and you don't practice it, there's very little chance that you will remember this. Why does the kid next to me have an A and I have a C or a D? Why is that? I'm just going to say, in a 7th grade classroom, it ain't because that kid's a genius and you're a dumber than a box of rocks, right? It's not that. It's because they figured out how to pass math class. Yes, okay, I will admit that the kid that is technically smarter has an easier time. But really what's going on is that, well, they're practicing it. A lot of times you sit in a math class, and myself included, I'm like, okay, I understand that. And if I don't practice it, it doesn't matter. I always go back to a sports analogy. Professional athletes practice every week. They don't just show up on the game day. They practice. They've been doing sports for longer than you have been alive. Yet they feel an urge and a necessity to practice.
There's no math in sports.
How many times have they made a free throw?
Okay, but like there's
I want to say probably, I might not even be exaggerating, a couple 100,000 times. By the time they turn 30, they've been playing sports for 20-something years. They've been throwing a basketball into the basket hundreds of thousands of times. Yet every single professional athlete over 30, their butt from Monday through Thursday is practicing. That seems ridiculous. It's just throwing a little thing into a little thing. Why do they have to practice? Because that's what the human condition is.
And plus,
If you don't practice it, you're not going to get good at it.
and math and sports.
For those of you that, do you think the professional athlete wants to practice?
yeah.
I'm just going to say, that's their job, right?
Yeah, they get paid like a lot of money for a football player. They get paid a lot of money.
That's certainly some motivation for sure.
You don't get
They're literally doing something so repetitive that they've done hundreds of thousands, yet they're willing to continue to do that. Well, it can't be just the money.
But it's also something that they like doing.
Ah, there's an important key right there. Okay. You think all professional athletes like every bit of what they do?
No. But
Well, so then therefore at some point they have to say to themselves, well, practice will make me better at it. I got to do it.
if you play like football professionally, wouldn't you like play?
Yeah, we're talking about the whole thing. I like to teach. I mean, I truly do. It makes me happy.
Unless you're an office worker doing
I
spreadsheets.
hate to grade papers. Right? I always say, my saying is, I don't get paid to teach, I get paid to grade papers, because that's the thing I loathe. Why do I need to grade papers? It's a chore. It's no fun, right? I grade it because it's part of the job. So I like, there's certain parts that I like, there's certain parts I don't like, right? Same thing with math. There's going to be parts that you like that are fun. There's going to be parts you don't like. You still have to practice it.
I used to like math until it got hard.
All right, you're in for a world of hurt. Oh, by the way, everyone said it was 360. That is the correct answer. See you
I
tomorrow.
decided I'm not going to high school. I have to, but I decided not to.
You won't graduate.
Yeah, that sucks because I don't want to be here. I'll just work. Nowhere.
Yes, you do. Eleanor, any questions?
Yeah, actually, it isn't about the math, but I was wondering, for in person, are you allowed to bring your backpack into class?
Absolutely.
Okay, thank you.
All right. See you later.
Bye.
Every class in my backpack.
I'm going to send the most responsible person in the class. That would be what? Maddie?
No.
Danny.
Yeah.
One to everyone in your next class.
Even though I don't like Danny, Danny is the most responsible. Yeah. Wow.
You could have said that slightly better.
What's this